And we're back. Yes. Excellent. Here we are, ladies and gentlemen. It is Thursday, January 14th. It's easy to lose track of all sense of time, and I don't know. Some of you might just be waking up right now. There's only 6 of you in the chat. That's weird. Well, whatever. 7. That's the breaks. I'm going to give people a moment or so to get into the chat, or to get into the live stream, I should say. And then I will explain what we're going to be doing today. Should be a pretty straightforward day. Reminder, you have about a week and a half till midterms. Oh gosh, he's already starting. You have a week and a half until midterms. A reminder that you do have a Google Classroom assignment due today in regards to the benchmark. Again, I do apologize for the addition of the benchmark once again. It was something that was out of my hands, but them's the breaks. All of a sudden, people dropped down to 3 in here. That's weird. It was like up to 6 or 7 at one point. They'll hopefully get back in or something like that. Anyway. But yes, I'm going to remind you of that benchmark before the end of this class period because I do need that done. And my explanation hopefully will benefit you in regards to grades and whatnot. So please make sure you're getting that benchmark done if you haven't already. I have today to wrap up something with you in regards to nth roots. Next week, we are going to be reviewing for midterms. That is my goal. Reminder that you have Monday off. You have Monday off. I don't have Monday off. I still have to be here on Monday for some reason. I don't know why. Despite the fact that I just read an article that said that cases are surging in New Jersey, and they will continue to be surging in New Jersey. But them's the breaks. Yeah. Oh, good. Now people are starting to flow in. I got 8. I got 9. Good. I got 10. Good. That's where it actually should be, you know. Genesis is still apparently having issues. We were told to hold off on entering stuff into Genesis for a day or so, simply because they've been having like severe issues with logging on and keeping things ready. So I still do have to keep an attendance, apparently, since y'all are virtual. So I am going to ask, and I'll remind you before the end of the class period as well for the people that are here, if you would be so kind as to leave a comment in the chat. Then I will have a record as to who is here, and that would be fantastic. If you would please take care of that before we actually get started. So yeah, what do I forget? Number 1, benchmark due today. I need that done. Number 2, midterms are not a week and a half. What am I talking about? They're like, a week and a half. About a week and a half, yes. But next week, we are going to be reviewing for the midterms. There are all them people, all them wonderful people. Good. Oh, goodness. It is, again, I'm on day 4 of this, teaching to an empty classroom. Again, I don't know. Just losing my mind. So, as for today, as I said, today is going to be somewhat of a straightforward day. I want to get a bit of practice in regards to nth roots, the things that we're working on. I was very deliberate with my lesson last class in terms of seeing what you could do with these problems. There's no one particular method for getting the simplified answer to these problems with nth roots. It's just a matter of seeing what the problem has in store for you and then reacting based on that. Spent a lot of time talking about that. So, for the first part of this class period, I would like to get done, and the quiz is up on the board in a moment. I'm going to strongly suggest that you utilize your notes from the last couple of class periods in order to remind yourself and to refresh yourself as to what it is that you have to do with these problems. A scratch piece of paper would be in order for some of these problems. Obviously, you have all your stuff in front of you right there. And for some, not all these problems, but for some of these problems, you may need to utilize the calculator in order to quickly be like, oh, what is 3 cubed or some junk like that? And then you can easily get that in the calculator. So I'm going to bring up the code. And I know that obviously there's probably like a 5 to 10 second delay or something like that. So I'm going to bring this thing over. Here we go. Okay. Classic. I want to shuffle those questions. I'm going to leave redemption questions on. I don't know why. I'm just in the mood for leaving redemption questions on. Just for funsies. Click. And then I'm going to bring this screen over to you. There you go. Now, obviously, being that you guys are all in the live chat, there's a giant glare that is directly on top of that code. I will do 2 things. Number 1, I will type that code into the chat. And I will write it on the board. 411391. I'm going to write that on the board as well for you guys to join in. Now, obviously, 391. Obviously, if I have people coming in late, there. Oh, he just said hi in the chat right when I said that. But if I have people coming in late, they can still join this quizzes as long as I'm actually running it live right now here with you. This quizzes. Afterwards, I would like to review certain questions, the questions that gave us the most. Like I said, it's going to be a very straightforward, easy kind of day. I'm not teaching anything incredibly brand new, but I would like to, again, get this information done with you guys here today. So if you would please all join this game, join myquiz.com. I put the code into the chat, 4113. Yeah, 411391, and I wrote it on the top right there. Once I click start, it will remain at the top of the board in white on the interface. So you'll see that when we get there. But please make the effort to log in right now, and I'm going to get this thing started. This quizzes, to answer any questions, is a practice. This is a practice quizzes. Of course, I am going to be assigning you something. You'll see. I am going to be assigning you something soon. But for now, this is just a practice that I would love to get done with you guys. So I see you all popping in there. I got 6 people so far popped in. I got 11 in the chat. So, where are y'all people at? Oh, goodness gracious. What a day. Yesterday, Genesis, well, it still kind of is, but Genesis was down all yesterday. People were having computer issues. It was just one of those crazy, crazy days. I mean, something went on in Washington, D.C. I don't know. But it's just one of them crazy days. It says I only got 7. Now, if you have not logged in yet, I'm going to go click start in a moment. But if you have not logged in yet, you will be able to join during the quizzes if you haven't. So please make sure that you do. This code will be good until I end the game. Once I end the game, the code will no longer be good. Okay? Like I said, have those notebooks ready just in case you need to reference something. I will be here to clarify things and to keep track. And we're not doing this the entire class period. I'm going to call for an end to it at some point so that I can begin reviewing with you guys. Here we go. Oh, I just heard someone else pop in right when I said that. There you go. I'm going to lower that volume. Okay. There are a couple players at the bottom. I don't know what happened to their computers. A couple players at the bottom who have only answered a couple of questions. It looks like they may still be answering questions. So what I'm going to do is I'm going to give you guys just another couple of minutes, keeping track of it on the clock over here. And then I'm going to end that game, and then we're going to review some stuff. Okay. So for you guys that are here, I would like to review some of these questions. It says I got 11 in the chat, but I don't know. But I would like to review some of these questions with you. And in order to review some of these questions, I would like to put these, well, not all of them, but some of these particular questions into your notebooks. So if you do not already have them out, I'm going to need those notebooks out and open. Now, what we're doing with these is going to play a role later on in this chapter. This chapter does take certain twists and turns. Now, I do have the chat open right here on my phone. So like I said, if you do have any questions, I can see what they are right there. I'm going to copy said questions into my notes, I should say. And let's see how this goes. So first, let's start with that one. I'm going to write this one for myself, and then I'm going to show you what I wrote. So in terms of the titles, I'm going to call this Nth Roots Quizzes Review. And today's the 14th. That's what I'm going to title mine. I'll show you in a minute. Example. The fifth root of 32, x to the 15th, y to the 20th, z to the 5th. Cool. And let me bring this screen up like that. Chapow. This is what I have. So you can see right there, I put the title. The title is Nth Roots Quizzes Review. Today is the 14th. And the first problem that I have right there is the fifth root of 32, x to the 15th, y to the 20th, z to the 5th. Now, I haven't looked at any of the choices yet, but I want to give this one a try first by hand. 32. Now, in terms of what I said the other day, I mentioned that you would have to do a little prime factorization tree if you wanted to of 32. You could break down that 32 as far as it could possibly go. In fact, if I were to bring up my... Oh, I don't have it. Where's my calculator? If I were to bring up my calculator... Come on. Come on, little calculator. There you go. If I were to bring up my calculator, it's fairly easy to figure out that 32 is nothing more than 2 to the 5th power. Now that's helpful. Being that it is 2 to the 5th power, there we go, I'm going to rewrite this in two ways. First, I'm going to write the 32 as 2 to the 5th. And second, I'm going to change the 5th root to a 1/5 power. Now, there's a bunch of reasons why I did that here, but it's mainly because I could see that every single exponent is a multiple of 5, and it is a 5th root. When you have something like that happen, where you have a 5th root and all of the exponents are multiples of that root, this is a very good strategy to partake in. Because when, and you are allowed to, when you distribute this 1/5 exponent to each term, each of the 4 terms, it's going to simplify each of those exponents. So if I distribute that 1/5 to all of them, 5 times 1/5 just cancel each other out. We're left with a 2. 15 times 1/5 will get you a 3. 20 times 1/5 will get you a 4. And of course, 5 times 1/5 will get you back to a 1. That's all that was inclined for that problem. Sometimes these problems have very straightforward solutions. Sometimes they don't. Let me take a look at the choices real quick for that problem. Yeah. It looks like a distribution between B, C, and D for all of you. A bunch of you realized the 2 and the, well, x cubed y to the 4th. Some of you just left the rest of them kind of by themselves, or maybe perhaps it might have been a guess. But yeah, that's what was entitled in the problem. Let's take a look at another one. Let's see here. After number 3. Oh, yeah. Let me write down this one. Example. And again, I'll show this to you after I write it down and walk you through the proper mindset. Okay? Chapow. Looking at this problem. First of all, recognize what this thing is saying. This is a 4 times the radical. This 4 is simply being multiplied by everything else. Leave it be for now. Just leave it there. This is a 4th root of 4096 x to the 8th, y to the 24th. Let's start by focusing on that 4096. I don't know what the heck is going on with this 4096. I have, but not many people have dealt with a number this large in terms of a radical. But we could try to break this thing down by prime factorization. I suspect that I could divide this thing down a lot. Let's see what happens. Going to my calculator. I can take 4096, and clearly I can divide it by 2. I know I can divide it by 2. Can I divide it by 8? Oh, sweet. I can divide it by 8. I didn't know if I could divide it by 8 or not. Let me go back. If you did 4096, if you did 4096 and divided it by 2, I wonder how many times I could divide it by 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I could divide it 12 times. So what is that? 2 to the 12th power? Yeah, 2 to the 12th power. It doesn't take that long to figure out how to break these things down. Now, 2 to the 12th power is interesting, especially when you take 4 and 8 and raise them to certain powers. Check this out. 4 to the 6th power. No, I did divide. Why did I do divide? 2 to the 12th. 4 to the, I want to say it's 6. Let me double check this. Yeah, 6. Nice, it worked. And then 8 cubed. Nope, 8 to the 4th probably. Yep. There's a whole bunch of ways to break that thing down. I'm going to stick to the 2 for now. It was 2 to the 12th. So let's rewrite this sucker. 4 times 2 to the 12th, x to the 8th, y to the 24th, all raised to the 1/4 power. Oh, come on. This thing screwed up on me. Come on, image mate. Work for me here. Sorry, my Elmo camera decided to crap out on me. Try to plug that thing back in, see if it works. Haha, it worked. Excellent. Okay. So I'm looking at this thing, and I recognize several things at once. First, I can break down that 4096 to be 2 to the 12th. Fantastic. But now, every single exponent is a multiple of 4. So I change my 4th root to a 1/4 power, and I can distribute that 1/4 power. Remember, distribution of exponents only applies if there is multiplication or division on the inside of the problem. So I can do that. I'm going to distribute that 1/4. What's this 4 doing right here? It's just hanging out. It's coming down for the ride. Don't worry. 4 times, 12 times 1/4 would be 2 cubed. 8 times 1/4 would be x squared. 24 times 1/4 would be y to the 6th. Now, I'm not done yet. 2 cubed is 8. 4 is just multiplying everything around. So 4 times 8, 32. Again, I haven't actually looked at any of the choices, so I'm assuming I'm right. I mean, I am right, because I'm always right. But this is a proper process that you could go through. Recognize the fact that, it's a 4th root, and all of these are multiples of 4. Let me change that to a 1/4 power, and then I can distribute it. Okay. Let me check the choices. So the answer was D, 32 x squared y to the 6th. Yeah, there we go. 4096 is not an easy number to be dealing with. It's not. It really isn't. But if you can break that thing down, and it only takes you a few moments to break it down with the calculator, break it down to its prime factorization, it becomes much easier to deal with. Let's see. Skip that one. Oh, no. I have to do that one. I know it was yellow, but I have to do that one. The 4th root of 64. The 4th root of 64. I have to do this one. 64 is a perfect square. 64 is also a perfect cube. 64 is not a perfect 4th power. It's not. It doesn't take too long to figure out that 64 is 2 to the 6th power. You could take 64 divided by 2. You get 2 to the 6th power. That is 64. But now I ask myself the question, something I asked last class, something that I emphasized last class. The only way that you escape a 4th root is if you have the proper exponent of 4. The only way you escape a 4th root is if you have a 4th power. That's the only way. Or a multiple of a 4th power. 6 is not a multiple of 4. It's not. So this is what I'm going to do next. You can break that 6th power up to be 2 to the 4th, 2 to the 2nd. Having that 4th power allows this term to escape. I'm going to take the long way and actually show you what happens here. There we go. This first radical just becomes a 2 because the 4th root and the 4th power cancel each other out. Unfortunately, that second term, nothing can be done with it. It does not have the proper exponent to escape. The only way that you're going to be able to break a number up like this and have stuff simplify is if the exponent is greater than the root. And in this case, it was. So I could break that 6th power up to a 4th and a 2nd power. That 4th power cancels with it, allows that 2 to escape. This 2nd power, unfortunately, sucks to be it. You're left with this. Now I'm going to do a couple things. First, I want to double check what the answers were, and then I want to talk about this 4th root of 4 real quick. Yeah, it looks like D, 2 times the 4th root of 4. Yep. There it is. Good. There we go. The 4th root of 4. A lot of people mistake what the 4th root of 4 actually is. Some people just look at the 4th root of 4 and they're like, 1. No, it's not 1. I'm sorry. It's actually 1.414 and change. The idea is that this decimal, when multiplied by itself 4 times, gives you 4. Check this out. Answer times, answer times, answer times, answer. I'm going to take that decimal. I didn't feel like retyping it, so I'm just going to do ANS to represent answer. But if you multiply that number by itself 4 times, you get 4 right on the dot. I love that kind of stuff. 4 to the 4th power, unfortunately, has to remain inside the radical. You can't simplify that. The only way you're going to be able to check to see if something simplifies, how do you know you're done? You have to check the exponents. Check the exponents and its prime factorization. Take a look at another one. Oh, there we go. Perfect example. Number 8. I'm going to write it down and then I'm going to show you. This is perfect. Boom. The 4th root of 48. V to the 8th power. Z to the 13th power. This is a perfect example. Now, just so you know, I write my Z's like that so you don't confuse them with 2's. I don't know what the heck is going to happen with this problem. I haven't even looked at the choices. But let me just follow the strategy that we talked about. Now, first of all, 13 is not a multiple of 4. So I can't follow that exact strategy that I did before where I changed this 4th root to be a 1/4 power. Unfortunately, I can't do that. Where do you start? Let's start with the 48. I'm going to start with the 48, and I'm going to find its prime factorization. Shouldn't take too long. 48 divided by 2. Oh, do it again. So I divided it twice, 3 times, 4 times, and then I got a 3. So 48 is in reality 2 to the 4th power times 3 to the 1st power. Oh, you can't see it. It's 2 to the 4th power times 3 to the 1st power. Because 2 to the 4th would give you 16, and then 16 times 3 would give you 48. Ms. Markey, how do I start these problems? Well, if you have a number like 48, find its prime factorization. The v to the 8th, you could do one of two things. You could leave it as an 8, or just to see what the heck is happening, I'm going to break it up. V to the 4th, v to the 4th. But now with the z, unfortunately, there's going to be something left behind. Z to the 4th, z to the 4th, z to the 4th. All of those give me z to the 12th when I add those 4s together. But there's an extra z to the 1st to account for the z to the 13th. Now, what can and cannot escape? This 2 can escape. This v can escape. This v can escape. This z can escape. This z can escape. This z can escape. The other 2 are stuck. This 3 and this z are left behind. So, ultimately, this is what's in front of the radical, because it was v times v squared, z times z times z cubed. And the 4th root of 3z is unfortunately left behind inside of the radical. There's nothing that can be done with the 3z. It did not have the proper exponent to be able to escape the 4th root. So it has to stay where it is. That's an amazing problem. I want to check the solutions. See which one actually worked. Goodness. 2v squared, z cubed, 4th root of 3z. Yep. Oh, I see. 4 people apparently chose the first answer, where they had a 4 instead of a 2 in front. That's interesting. That is interesting. All right, let's do a couple more. I'll come back to that one maybe. Oh, that one. No, that one. Perfect. We'll do this one. Average time, 5 seconds. I love seeing the average time on there. This is the 3rd root of negative 256. the third root of negative 256. Well, again, let me apply my strategy. First of all, that negative I'm going to count as a -1. Because as we talked about last class, you can take the cubed root of a -1. You can. You're allowed to. It's perfectly acceptable. 256? I don't know what to do about 256. So let's break that thing down. Let's find its prime factorization. Clear that. 256 divided by 2. I'm going to keep track of how many times I can do this. 1, 2, 3, 4, 5, 6, 7, 8. I was able to do it 8 times. Double check. 2 to the 8th power, clearly 256. Okay. So let's break this thing up like this. Third root of -1 times 2 to the 8th power. Now, like I said, I'm going to treat that -1 separately because I can take the cubed root of -1. But that 8 does not have the proper exponent. So I'm going to have to break this 2 to the 8th up. I'm going to break it up like this. There we go. I was able to break it up as 2 cubed because it needed to have the proper exponent to escape. But that 2 squared can't. And I'm allowed to break it up like that, well, because 3 plus 3 plus 2 gives you 8. The cubed root of -1 is allowed to escape because -1 times -1 times -1. It's one of those special cases. This 2 can escape, and that 2 can escape. The remaining 2 squared, sorry, it is stuck. That would be how I would write the remaining answer. -1 times 2 gives you -4, and that remaining 2 squared, which is a 4, is stuck. It is left behind inside that problem. I love this problem. There's probably not many problems I don't love. Looking at the answers, B was indeed the answer. Got that one right there. I'm just looking, it was kind of across the board. I think people may have been guessing, perhaps. But what I have is indeed the answer. Again, flipping that one back so people can see it a little bit more. That is indeed the answer. Amazing. Let's see what else we got. Oh, heck yeah. Let's do number 15. Average time, 10 seconds. Now, this problem is the one that I'm going to wrap up with today. I'm going to do this problem, and then that's going to be it for today. But let me tell you, number 1, if you haven't left a comment in the chat, if you haven't, they are requiring me to take attendance, especially with Genesis screwing up. So I'm going to need you to do that for my records. Number 2, benchmarks. Do not forget that you have a benchmark due. Get that thing done. Read the directions that I left in Google Classroom. You'll understand why when you read them. Number 3, next week, we are going to be reviewing for midterms next week. 2 class periods, Tuesday, Thursday, because you have Monday off. And then the 25th, supposedly the week you get back, I'll believe it when I see it, that's the week of midterms. Oh, happy day. Let me write this problem down. And this will be the last one we do today. Now, part of the reason why, there's actually two reasons why I think this problem is amazing. Number one, nobody got it right. Number two, you don't see 567 all too often. The first thing that I would try, now, first of all, this is a square root, according to the problem. But the first thing that I would try to do, regardless of what type of root it was, would be I would try to take the prime factorization of 567. Clearly, that number is not divisible by 2. It's not. So let's try to divide it by 3. There it is. 567 divided by 3. Sweet. Let's try to divide it by 3 again. Sweet. Let's do it again. So that was 1, 2, 3, 4. And then I got a 7. So this is in reality and I'm writing this and then I'm going to show you, but I want to double check something real quick. 3 to the 4th times 7. Yep, 567. That's what I got right there. Prime factorization. Regardless of what the root is, that would be the first thing that I would try to do. It's a square root. Meaning the only way you're escaping a square root is if you are a perfect square. This negative 10 is just coming down for the ride for the time being. Let's see. Square root, 3 squared, 3 squared, 7 to the first, x squared, x to the first. Let me zoom in on that a little so you can see a little bit better. The only way I'm escaping a square root is if I am a perfect square. It's the only way it's going to happen. So I break up that 3 to the 4th. The 7, unfortunately, stays the way it is. But then that x cubed could be broken up 2 and 1. This 3 escapes. This 3 escapes. This x escapes. Oh, can't see it. There it is. As a result, see if the glare's in the way. Hold on a sec. Make sure that glare is out of the way. There we go. A little bit better. But as a result, this is really 3 times 3 times x. Well, that's really 9x. But it's 9x times negative 10. It's like all these extra little bells and whistles happening. I can't even talk. This should really be negative 90x then. Times the square root of 7x. I need the glare out of the way. Move that down a little bit. There we go. The 3 and the 3 escaped as a 9 because it was 3 times 3. That 9 was times negative 10, gave you negative 90. That x escaped just become an x on the outside. And that 7 and that x on the inside stuck. Let me see if they agreed with me. Come on. Japan. Yep. They agreed with me. 5 of you chose C. That's interesting. That's interesting. But yeah, that's what I got. I love this problem. But again, there are not many problems I don't love. So, you need to get that benchmark done if you haven't already. We're going to be reviewing for midterms next week. I'm going to be assigning something else, obviously, through Google Classroom, so be on the lookout for that. Probably assign it tomorrow. Yeah, probably sign it tomorrow. But in the meantime, I'm going to end class at this point. The time is approximately 10:23 in the classroom, according to the classroom bell. Weird. I wish they would fix those clocks, but I am going to dismiss you from here. If you haven't already commented in the chat, please do so. Otherwise, please take your stuff with you as you exit the classroom. Do not leave stuff under the desk and socially distance in the hallways. See you guys. Bye. 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 Thank you guys. Bye.